Hi, my name is Henry Wu, and today I'm gonna finish my AOL 1 Unit 1. And today it's March 25th. And we'll begin with question 1, part A. So what I'm gonna do is um, use the x plus 27 with the power of 1 over 3 as, so you will represent this thing right here, and then now we can just plug in x equals 0 right away, and then we will get u equals 3. And then because we have to solve this equation here, so um we have to define how u represents x. So we'll just take the equation above here into this. So x plus 27 equals u with the power of 3. So now we just simply take 27 to the right. So it'll be x equals u cubed minus 27. So now we can just plug u right into the limit thingy. So it'll be limit u approaches 3, and then u minus 3 over u cubed minus 27. And now we notice here u cubed minus 27 is difference of cube. So we can actually factor it into, just write these down first, and then u minus 3 here times u cubed plus 3u plus 3 squared is 9. So now we can cancel out u minus 3 here, and then we just plug in u equals 3 right away. So it will be equals to 9 plus 9. Oh no, that's not 9 squared. Sorry. It's 9 plus 9 plus 9 over 1. 1 over. So it's basically 1 over 27. So the answer will be 1 over 27. And that's part A. So now we're gonna proceed with part B. So part B will be, so first when we look at this equation, we're gonna rationalize the denominator here. So it'll be limit x approaches 10, x minus 10, and then we can factor this into x minus 1 minus 3, and we can use the difference of squares. So just copy down this, and then it'll be plus 3. And then also over here, it's also plus 3. And now it will be equal to limit x equals 10. And then we don't have to figure the part over here just yet. So we just write it down right now. Plus 3, and then we times, so it'll be, no, let's take it off. So it'll be x minus 1 minus 3 cubed. And then we notice here, minus 3 cubed minus 1, it's also minus 10. So it's also x minus 10. So we can just cancel out x minus 10 right here. And so we just get limit s when x approaches 10. It's x minus 1 plus 3. We just plug in x right away. So it'll be limit x towards 10. Sorry, the handwriting. And then 3 plus 3. Oh no, we just get rid of that right now. So the answer will be 6. So part B will be equals 6. Now we're gonna do question number 2. So it's asking that f of x have to be continuous at all values of x. So basically, this point in the middle have to exist on both of these equations. Oh, I don't mean to do that. Like this. So we basically just plug in x equals 2 into the equation, and the f of x have to be -9 to fulfill the continuity, yeah. So now we're gonna do the bottom one first because there's only a. So it'll be 2a minus 5 because we just plug in x right away, then it will be equals to 5 minus 9. And then we just factor it, and not factor. We can just so it'll be 2a, move -5 to the right, be -4, and then a equals 2 minus 2. And then now we can solve b right here. Just plug it in the first equation right here. It'll be -2 because it's a, and then times 2 squared minus bx plus 1 equals 2 minus 9. So -2 times 2 squared, it's -8. -8 plus 1 is -7. And then we move it to the right. So it'll be minus bx equals -2. So x is basically 2. So can get to know b is actually 1. So this will be the answer. A equals -2 and then b equals 1. Now, it's gonna be the question 3. So what this question is talking about is basically an object falling from the sky. Yeah. And then by the height of 553 meters. Because when x equals 0, it's 553. It's a starting point. So now we're gonna finish part A. So how do we do that? We have to find the average velocity during the first 4 seconds. So it's basically find the height at second 4 and then minus um the height in the beginning. So when second equals 0 and then over the duration, which is 4. So we just simply just plug it into this equation right here on the h of x. Plus -5.25 times 4 cubed, 4 squared plus 553. I'll just get this out of the way. And then plus 5.25 times 0. We don't have to do a square. Minus 553. And then over 4. And then we can just cancel out 553. And then basically 5.25 times 0. Oh, sorry. 5.25 times 0, it's 0. Then now we can cancel out 4 here. So the it will be like this: 5.25 times 4, and then minus, it will be is it 21? Yeah, 21 meters per second. So the average velocity during the first 4 seconds of the hammer dropping will be -21 meters per second. And that's the full answer for question part A. And now we're gonna proceed to part B. So we're gonna find the exact velocity at x equals 4. So using the first principle is basically using the limits. So limit when at h approaches to 0. So we're gonna write down minus 5.25 x x plus h cubed, and then plus 553, and then it's plus 5.25 square, and then minus 553 over h. So it will equal to, oh, we can cancel out 553 right here. And then um, it will be limit h towards 0, 5.25 times x squared, and then it's 2xh is 2xh times 5.25, so it's minus 10.5 xh. Is that right? Yeah. Yeah, that's right. And then plus, oh no, it's minus 5.25 x squared, and then plus 5.25 x squared over h. And then will be, we can basically cancel out 5.25 x squared right here, and then we just write it down right here, I guess. um 5 h minus 5.25 square, and then over h. And then it will be, we can take out h, I mean minus h. Yeah, I think it's, yeah, we can take out minus 5.25. Yeah, is it? Yeah. Limit towards 0, and then x, oh no, we can basically plug in x right now, so we don't have to do it like that. So we just plug in x equals 4 right here, so it's minus 42 h, I mean minus 5.25 cube h cubed over h, and equals to, we're just gonna factor it, so it's minus 5.25 h out here, and then h minus what's that, eight. It's 8. Yes, I think it's 8. Yeah, over h, and then we can just cancel out h, and then get h equals 8 minutes per second. So the average velocity of the hammer will be h equals 8. And that's the end exactly at 4 seconds will be x equals 8, and that will be the end of my LL1. Oh, sorry here. It's not h equals 8. I forgot, right, to write the limit here, h towards 0. And then now we just plug in 0 for h. So the answer will be 8 minutes per second. So the exact velocity at x equals 4 will be 8 minus 8 minutes per second. And that's the end of my LL number 2. Oh, sorry, that's L.